So in this video, we're going to look at some more advanced balancing concepts. We're also going to look at predicting products to reactants, or to reactions rather, and we're going to be checking on how to predict a product. So let me get my pen going here. And we'll move on. So the first thing we want to talk about are the types of reactions. There's 6 types of reactions. You're going to want to memorize these. And they're all going to follow like a general form, okay? So we're going to look at both of those in some depth here. So the first one is the synthesis reaction. The opposite of synthesis is decomposition. There is single displacement, sometimes called single replacement, and double displacement, which can also be called double replacement reactions. There are acid-base neutralization reactions we're going to look at, which these are actually a special form of double displacement. And we're going to look at combustion reactions, so burning things. And the goal is to be able to look at a reaction and classify it as one of these 6. Now, there are obviously many more types of reactions that we could talk about, but these are the main 6 that we're going to cover in my first year chem class. Let's look at synthesis. So here's a great example of synthesis. Carbon and oxygen is going to react, and this is a synthesis reaction, so I can predict that I'm going to make a single product, right? I have 2 reactants. I'm going to synthesize them together to make one product. In this case, it's going to be CO2, carbon dioxide. The general form for a synthesis reaction is A plus B yields AB. Now, notice something. These are single species, all right, or elements. So it's just carbon or it's just oxygen. It's not, it's not usually big compounds. All right. Now you could find some synthesis reactions that are a little more complicated than this, but the general form, right, just the rule of thumb is single element plus single element is going to make a new compound. Here's a great example of a synthesis reaction. Potassium and chlorine making potassium chloride. So this is a salt. All right, I know it's a salt because I have a metal and a non-metal bonded together. You can see that this has that really nice crystal structure. It's white and solid at room temperature. All right, and I know all these things about the product of this reaction without ever doing the reaction itself, because I can recognize, hey, I have potassium by itself, I have chlorine by itself, so this is going to be a synthesis reaction. All right, it's going to make that salt. Now, we do want to be able to predict products from our ability to recognize and categorize reactions. So if I just give you the reactants, hopefully you'll be able to say, what are the products going to be? Well, in this case, I have 2 single elements. So again, we're working synthesis. So I'm going to make NaCl. It's going to be a solid. All right, now we would need to balance this. All right, that is important that we balance things. So right now we have 1 sodium, we have 2 chlorines, and on this side we have 1 and 1. So I'm going to throw a 2 in here to fix that, and I need to throw a 2 right there to fix that. So 2, 1, 2 would be my balanced equation. All right, here would be another one, right? I have magnesium and I have fluorine. All right, notice this is going to be, let's see, magnesium is +2, fluorine is -1, so I'm going to get MgF2. That's an M. Mg, right? From our cross-charge method. So that's going to be a 1, that's going to be a 2, right? We're going to bring those charges down and drop the signs. Now, in this case, it's actually 1s all the way across, right? 1 magnesium on both sides and 2 fluorines. Here's another one, aluminum and fluorine. Now, we know that aluminum is always +3. That's a rule. Fluorine is -1. So I'm going to get AlF3 as my salt. I'm still using the cross-charge method. So 3 comes down and 1 comes down. Drop the sign. And when I balance it, I have 2 and 3, so I'm going to put a 3 right there, a 2 right there, and a 2 in front of aluminum. That gives me 2 aluminums on the left, 2 on the right, 6 fluorines on both sides. So there we go. Oh, and here we can see some connectors. Yeah, there we go. Works every time. Make sure we balance them. And there we are. I forgot I put those in there. All right, let's look at the second type. Let's look at decomposition. So this is the opposite of synthesis. So just have NaCl as a reactant. It's going to break apart into Cl and Na. General form for this is going to be AB, so a single reactant breaks down into 2 products. It breaks down into its parts. Now, I want to see if I have, no, I don't. So when you're breaking things down, look for your diatomic atoms and make sure you give them their 2, right? So Brinkelhoff, right? If you see any of those guys by themselves, they have to have that 2 there. Here would be a great example. Here's mercury 2 oxide. And if you heat it, it will break apart into elemental mercury, which you can kind of see right there. All right. And oxygen gas, which would be probably leaving my test tube, right? We would not heat this under a stopper, right? It would, that'd be dangerous. So the oxygen is probably leaving, but there we go. There's a decomposition reaction. All right, so let's look at the third, single displacement, all right? Zinc plus copper chloride, copper 2 chloride. Notice something here. I have a single metal by itself, and it's going to displace something. Metals are going to displace the other metals. So copper is going to end up by itself. Quit that. There we go. Copper is going to end up by itself, and zinc and chlorine are going to form a bond. All right. There we go. In this case, right, I need to know that zinc is always +2. There's a rule in order to get this thing to balance out, right? So remember from your common charges that silver, which is Ag, is always +1. And then right above it is zinc, which is always +2. And then we have aluminum, which is always +3. And then there is carbon, which is usually ± or -4. So there's this nice little staircase on the periodic table. We need to know those, right? The general form for a single displacement is AB plus C makes AC and B. So our rearrangement that's going on there, okay, is just the metal switching spots. Now, in this case, we actually have what's called an oxidation reduction or a redox reaction. We'll talk more about those later, but redox is pretty interesting. It just tracks the charges on the species. So I'll just give you a quick intro to this, and we'll see some more later. So any metal by itself is 0, all right? And in this case, because I have 2 chlorines and they're -1 each, copper must be +2. And over here we have still -1, -1, so zinc is +2. And so zinc was oxidized. It went from 0 to a -2 charge, or sorry, to a +2 charge. And copper went from +2 down to 0. So it was reduced. So if we think about the charge on a number line, right, here's 0, here's +2. It started here, copper did, and it was reduced to 0. So when we talk about oxidation reduction later on, we'll see this again. We'll learn this right here, oil rig. So oxidation is loss, reduction is gain. I'm talking about gain of electrons. So if I'm reducing my charge, I'm gaining electrons, right? I'm gaining negative charges, and that's making me jump, from +2 to +1 down to 0. If I am oxidized, then I'm losing electrons, so I should be becoming more positive. So more positive, more negative. We'll look more at that later, but single displacement always comes up with redox. So here's a great example of a single replacement reaction. We have lithium by itself as a metal. We have some water here, all right, which is, AB compound, right? AB, there it is. This will be our C. And so we're going to break it apart and we're going to get our new stuff. So in this case, we're going to make aqueous lithium hydroxide and we're going to make hydrogen by itself. Look at a couple of those. So here's the first, or no, sorry, this is not the first one we looked at. Zinc and hydrochloric acid makes zinc chloride and hydrogen gas. All right, we want to balance that out. So 2 there, and we're good. Now, how did I do that fast? Well, zinc's a 1 on both sides. Hydrogen is 2, so I need to fix that hydrogen. Chlorine is 2, so I just throw that in there. All right. Salt and fluorine make sodium fluoride and chlorine gas. All right, well, same thing. I'm going to look at this and I'm going to go, all right, well, I've got 2 chlorines. That gives me 2 sodiums. That gives me 2 fluorines. Hey, I'm good. There we go. All right. Now, we do want to be able to predict our products. So in this one, I'm giving you just the reactants, and I want you to predict and balance. So I need to be able to identify the 2 metals. There they are. I need to know aluminum is always +3 and nitrate's -1. So we'll do a little scratch work up here. Aluminum's +3. Nitrate is always -1. So I'm going to cross the charge and drop the sign. Oh my goodness, pen work. 1, there we go. 3, so I'm going to make Al NO3 in parentheses 3 plus copper by itself. This, by the way, would be a great example of a redox reaction. Now I need to balance it. All right, so I'm going to balance it by grouping. So I'm going to group my nitrates together. So I've got 3 on the right. I've got 2 on the left, right? 2 nitrates there, 3 nitrates on the right. So I'm just going to switch that out front. All right, switch those 2. That gives me 2 aluminums. That gives me 3 coppers. All right. There we go. Get rid of my stuff there. I want to drop that in. Okay. Double displacement. So double displacement is going to be a lot like single displacement, except instead of having a single element, we've got 2 binary compounds. So binary meaning 2 species or 2 groups. So magnesium and calcium are still metals. They're still going to switch. All right. There we go. We're just going to switch our advanced partners. So these 2 go together and those 2 go together. The general form, AB and CD makes AD and CB. So we're just flip-flopping our metals. Now, when you do these, when you try to predict these, we can kind of think about it like you did foiling in algebra. So you do first, outside, inside, last, right, in algebra. So we're going to do the first and the last, all right? And the inside elements are going to go together. We just need to remember that our metal needs to go first, right? So silver and chlorine come together. They make silver chloride, right? Silver is always +1, chlorine's -1. So when we cross the charges, they're both 1s. Sodium and nitrate. Sodium is always +1, nitrate's always -1, so they balance out. In the second one, we've got nitrate and we've got sodium. Now, when you're putting these together, you ignore this for the right side. Sodium's -1, potassium's +1, so I just get I just get KNO3. All right, barium and sulfate come together. Barium is +2 and sulfate's -2, so the charges, when they cross, cancel out. We have to reduce them. All right, and when we balance it, we would end up with just this 2. Let's try a couple of these. All right. Metals swap. So when hydrogen comes first, it's a metal. So there are my metals. I need to flip-flop them just like that. So I'm going to get AgCl. Okay, Ag is always +1, Cl is always -1, so just AgCl. All right. The next thing I'm going to get is H, which is +1, and NO3, which is -1, so HNO3. I don't need to balance it. It's already balanced. They're all 1s. So look at the second one. I've got sodium and I've got chlorine, or sorry, calcium are my metals. So sodium and chlorine are going to end up together. NaCl, +1 and -1. And then I have calcium and I have phosphate. Now, calcium is +2. Phosphate is -3, right? Remember that? So we're going to switch the 3 down and the 2 down. So we need to put phosphate in parentheses. So we're going to come up with Ca3PO4 2. Now we'll balance this by grouping. So 2 phosphates on the right, need 2 on the left. I've got now 6 sodiums, so I need 6. That gives me 6 chlorines, so I need a 3 right there to give me 6 on the left. That gives me 3 calciums, and I have 3 calciums, so that's a 1. All right, barium and nitrate for number 3. Barium is +2, nitrate's -1. So barium is +2, nitrate -1. So that's going to be a 2 and a 1. We need to switch them. So BaNO3 2. All right. And then I have lead and I have chlorine. Now, lead's a transition element, so I have to figure out its charge by uncrossing. There's a 1 right there, and that matches the -1 that should be on nitrate. So that +2 must be the charge. So I have Pb +2. And then I'm going to put it together with chlorine, which is -1. So I'm going to have, that should be a P. Hold on. Come on now. Where's my eraser? So it should be PbCl2. Again, we'll do this by grouping. So 2 nitrates. Let me get rid of that stuff on the left. There we go. So 2 nitrates, 1 lead, 2 chlorines, 1 barium. So these are just all 1s. It's already balanced for us. Nice. All right, 2 to go, right? We have sodium and chlorine. Hopefully by now you're seeing that sodium and chlorine is salt, and that's something that we can spot. And I'm going to have iron, and I'm going to have hydroxide. Again, I need to uncross the charge from this species. So that's a +3 and a -1, so that works. So I have iron as +3, and I have OH, which we know is -1. So 1 and 3. FeOH3, so iron 3. Whoops. Oh my goodness. Getting ahead of myself there. We have iron 3 hydroxide. Now we'll do it by grouping again. So I have 3 hydroxides on the right, so I need 3 on the left. That gives me 3 sodiums, which gives me 3 chlorines, which I have 3 chlorines. I have 1 iron. I have 1 iron. We're good. There we go. 1, 3, 3, 1. See, grouping is way better, right? Way better. All right, last one, copper and potassium. So they're going to switch partners. So we're going to have K and we're going to have SO4. So we know that K is +1. We know SO4 is 2-. So we're going to have K2SO4. And then we're going to have copper, which we need to uncross the charges. We know sulfate's -2. We don't see anything there on either side, so the 2's must have reduced out. So copper must be +2. And we're going to put it together with hydroxide, which we know is -1. So 2, 1. So CuOH2. So we have 2 hydroxides. We need 2 over here, 2 potassiums. We're good. 1 sulfate, 1 sulfate, 1 copper, 1 copper. There we go. All right. So that is predicting the products. Now, double displacement takes a hot minute because you got to do some cross charge method, but it's not impossible. All right. And that's really going to help you when you get to acid-base neutralization because it's just double displacement, except we're going to make water as one of our compounds. The water is going to be formed from the H on the acid and the OH on the base. Right? There's our water, which is going to leave this metal and this non-metal species to form the salt. As always, don't forget to balance, all right? But when you're predicting it, it's the same thing as a double displacement reaction, so that's a good thing. The last type are the combustion reactions. They are anytime a hydrocarbon reacts with oxygen gas. Now, it's very important that this is O2, right? We used to call this burning, right? And in order to burn something, you got to have the 3 things in the fire triangle, right? You have to have a source of ignition, you have to have a source of fuel, and you have to have a source of oxygen. So heat, fuel, and O2. And that's always needs to be present. Combustion reactions have a general form that's a little bit different than the other ABC general forms we've seen. In this case, here is our hydrocarbon. So it's a hydrocarbon. carbon. We have molecular oxygen. We always make CO2 and water. Now, in real life, okay, you're going to make some things like carbon monoxide and some other, not so great stuff. That actually comes from incomplete combustion of the hydrocarbon. We're going to assume when we're talking about a combustion reaction that we're getting a complete combustion, so we can just assume CO2 and H2O. Anytime that we burn something, we're making a combustion reaction take place. We're always producing that stuff, right? Something that I would recommend you memorize. Octane is the hydrocarbon in gasoline, C8H18. Okay, that's a good chemical to know. When we look at combustion, here's a combustion reaction. All right, and we're going to balance this thing. So I can't really balance this by grouping, so I got to go back and do it the old-fashioned way. Now, notice something. These coefficients, all right, are a little bit bigger than normal. Okay, normally we're used to like 1s and 2s and 3s, maybe a 4, but definitely not 6s or 8s. When you do combustion balancing, you can get much bigger coefficients. I mean, things like 17s and 14s are not uncommon. It's really, really important that you try to leave O2 to the very end, right? Always balance last, all right? So now let's actually do one of these. We'll go back. Okay, so let's walk through this. So I'm going to do it the old-fashioned way, right? Where I make my list. I can't do grouping. All right, so we have 1, and then for H we have 2, and for O we have 3, right? We have 1 here, and we have 2 there, okay? Or we have 2 here, sorry, well, and 1 there. So 2 and 1 make 3. Well, the rule is always leave O and H to the end, so I need to do carbon first. So I'm going to put a 5 there. That gives me 5 carbons. 10 plus 1 gives me 11 oxygens. All right, well, can't do a 2 to 11, so I'm going to do a 2 to 12, so that gives me 6. So 6 times 2 is 12. Now I have 10 oxygens here plus 6 there. That gives me 16. All right, 2 times 8 gives me 16. So 5, 12, 16, 5, 12, 16, everybody's good. So that must be a 1. Sure enough. All right, let's say I gave you something and said, hey, predict the products. You're like, oh, what, this is not single displacement. I mean, it's combustion, right? We have hydrocarbon, CXHY, right? Some subscripts for CNH. O2, it's always going to make CO2 and H2O. Right? I will let you guys balance this one. Okay, but again, you're just going to follow a very similar pattern that we did above. And remember, you can get big numbers in combustion. So to finish up, we're going to look at some mixed practice. All right, so we're going to state the type, predict the products, and then we're going to balance. So we'll start by just doing the type. So here we have 2 binary species. So this is double displacement. This one is going to be combustion because I have a hydrocarbon with oxygen. I have a metal by itself and then a binary compound. So this is single displacement. CS and BR, this is going to be synthesis. All right. HCl and NaOH, this starts with H. NaOH ends in OH, so that's acid base neutralization. All right, and I only have one product here, or sorry, one reactant. Wow. So that is a decomp reaction. All right, let's go through and double displace some of these things. So we've got barium and sulfate. Both of those are plus and minus 2 respectively. So I have BaSO4, and it's going to give me H and Cl. H is plus 1, Cl is minus 1. So there we go. For combustion, that one's easy. I know I always make CO2 and water, right? Just knowing the name of the reaction is combustion tells me what the products are. Single displacement, all right, well, we know zinc by rule is always plus 2. Sulfate is minus 2. So I'm going to get zinc sulfate. The charges are going to cancel out, right? Zn plus 2, sulfate minus 2. So when the 2's come down, right, we always reduce. So we divide by 2 and we get 1s. Okay. So we got zinc sulfate and we're going to have copper all alone. Cesium and bromine. This is a synthesis reaction, so I just need to cross their charges. Cesium's in group 1, so it's +1. Bromine's a halogen, so it's -1. So I'm just going to get CsBr. HCl and NaOH, well, this is acid-base, so I know I'm going to make water. And then I'm going to have a salt. In this case, it's table salt, NaCl. Last one is decomp, so I can expect it's going to break into a metal and a nonmetal here. So I'm going to get iron by itself, and I'm going to get some carbonate. All right. We'll just leave it at that for now. Okay, there we go. We can go through and balance these, right? We can do grouping for most of them. I'm going to let you guys work your balancing. If you can't figure out how to balance one of them, just let me know, and I'll be glad to give you a hand, all right? So this is pretty much it for the balancing unit, all right? Make sure that you can predict products. Make sure that you remember to cross the charges, balance by grouping, all that good stuff, okay? So if you have questions, absolutely let me know, and I'll be glad to give you a hand.